All right, hello everyone, Professor Dustin here. This video is going to be what to do after the first night of observations have been done on our supernova project. So the idea here is that you send the instructions to the telescope after you've identified a source and you've put the first night of observations, which is a little bit of a test night. We're still sort of getting a feel for how long the telescope exposures have to be, what sources are actually reasonable to observe, that kind of stuff. So still a test, but I think this process will help us. If we've gotten a source that works, this will help us make sure that we actually get the rest of the light curve. Because of course, and this is time critical, like, depending on when we start, really have like 10 days or maybe less to get the part of the light curve we want. So we have to be efficient with that time. So the last video finished at point 1 here. Enter this information in the next section of the spreadsheet, reserve 5-ish days. And over here I have the spreadsheet. This is my line. I decided New Mexico, that's the time, 2:30 to sunrise, transit at 3 o'clock. Test case, some notes about what I was doing, and here's the telescope. This is the exposure that I'm using, 2 times 5 minutes at bin 2 with 2 filters. So now what I want to do is go and basically do step 2 here. Download the data, open an Astro Image and stack the images if I have to. So let me just mention that I did get an email from iTelescope indicating that it was used. So this is what the emails from iTelescope look like. Took 4 images, cost us 35 points, and here are the pre-images. You can see that this shows that the sky was clear at some point during the observations. There should be a galaxy in here. There just barely isn't. So probably, it's kind of like there. So I'm not optimistic about this, but I think we still have to go through the process, because if the supernova is there and we observed it, it's kind of our responsibility to record what we observed, and actually we can submit it to the data archive still. So I'm going over to iTelescope, going to links, going to download my data. This was T11. The source is SN 2022-8HF. This was an old one that kind of didn't work, so I want to do the new one, which is probably going to be slightly better. The way that I name things, I do 2022, 0208, so that I keep track of what days the observations happened. I have a separate system for keeping track of the sources, but when we store raw data, we kind of want to store things as days and then separately record what sources we're looking at. Okay, so here's the zip file. I'm going to download that. I'm going to download it to some kind of temporary place. I would advise having some better organization, since I don't have a place for this one because it's sort of just a test, and based on what's happening today, I might just need to abandon it. So anyway, saving the zip file. Then I'm going to go into where that thing is and unzip it. As I said before, if you're on Windows or a Mac, this process will be different, but the end result should be the same. So just let me do this real quick. Sorry. There it is, 0208. So unzipping that and getting into there. Want to get rid of the JPEGs and the RAWs. So, and of course, you could do this or not. We don't need them for sure. All the calibration's been done for us. So that's just left with the calibrated. Well, I ran those wrong. Okay, so now unzip the calibrated ones. And I'm going to go back in and actually remove the zip files now because they don't need them. Okay, so now I should have just the FITS files in there. You can see their name, UUII, bin 2, 300 seconds. So now I want to stack them. So stacking is a process which I described in another video. You can actually see that it's doing, Astro Image is actually doing a little buggy thing. There's no other file menus up here. Usually the process for me is to just restart it, and then that usually works. Yeah, it's either back or whatever reason. Okay, so I'm going to open, remember how Astro Image works. You have to open one, and then you can open all of them. And I want to open them in sets of filters. So, oh God, I cannot see there's the galaxy. Oh my, this is going to be tough, but okay, here we go. So open the image sequence. I want to start, let's start with I. I want to do 2 images that have just I in them. So that now says I'm down to 2, so that made sense. Now I have 2 images, and you can see they are not lined up, right? You can see this star in particular right there is shifting a bunch as we go. So those need to be lined up. But what's nice is that the WCS actually worked. So because this WCS is here, it means that we can do the alignment. I will have to make a separate video on how to deal with the alignment for sure, if that's not there. So align stack using WCS or apertures. First slice, last slice, we don't need to worry about any of this. We just want to use the WCS headers for alignment. Show help panel, usually I leave checked because why not. And it will alignment, and it will set in a separate subdirectory called aligned. Cool. Close these. I'm going to do the same thing with the U images. U. Oh my God, these are so dim. I mean, most of the things here, you can see most of the dots are actually cosmic ray hits because you can see just these little, like, yeah, I'm not optimistic about this. Okay, anyway, so let's just stack them. There's no WCS on these guys. Okay, so I'm going to attempt to put a WCS on this. Actually, I think what I'm going to do is I'm going to pause here. I'm going to make another video on how to do the WCS and put it over there so that we have it's two separate videos. So if you're in the situation of needing a WCS, check out that video. If not, you can do it here. You can continue out here. And another failure. You can see it failed twice, right again, failed twice. So the fact that it's not timing out makes me think that the thing is actually finding stars and the thing is just working. There's just not enough stars in the image. So probably we should know that T11 filter U requires longer exposure time, because if this was a 600-second exposure, we wouldn't have to do the stacking, right? We could just take the observation as it is, it's just 600 seconds, same exposure time as stacking two 300s. So I'm gonna now show you a workaround, which will work for us because what we are interested in is just what's happening at the center of the image. Now, of course, I hope this workaround works. That's what workarounds are for. We'll see. So I first want to clean off the apertures here. So I'll click that button to do that. We see some stars. Now I don't see a ton of stars. One there, there's one over there. All the dots are hard to say. You can flick between them to tell which ones are cosmic ray hits and which ones are stars. Those are stars. Those are the same stars in either image. So if I just tell Astro Image J that they are the same stars, then Astro Image J will go, oh, I can line them up that way. So this will be better in the center of the image than away from at the outside of the image, but we want the center. So I'm going to try to do this way. So the other images are already stacked. I did that in the other video. I'm going to do this now, just stack these two images on top of each other doing this way. So I'm going to align the stack using WCS or apertures, but I can't use WCS because we don't have one. So I'm going to go to, I think, single step mode. One click sets the first aperture in each image. Yeah, so I have no previous apertures. I don't have an RNA deck. I don't want to change the apertures. I think this is what I want. I want to turn on the help section so that I know what I'm doing. Okay, so I've got a little help window up here. Add target star aperture T1, left click. So I've got the super bright star here. Definitely want to left click on that guy. Add more reference star apertures or delete apertures, left click. So so I can delete the one I just placed if I want, but I want to add more. So I'm going to just keep left clicking on stars that I see. And I'm only going to do 3 because I only see 3 that are super bright to me. I see a bunch more. So maybe if you wanted to do a good job, you could do more. I've set those 3 apertures. Now I want to click enter, I think, enter, finalize aperture selection, align the image, and move to the next image. So I'm going to do that, click enter. And now I'm going to have to select those same 3 stars again. Yeah, so because I selected one click, I just clicked the first one, the other one's auto-populated, virtual stack image complete, aligned images saved in a subdirectory. Okay, cool. Let's try to stack them. Okay, so that was a little bit of a detour. Okay, so now we're over here and we want to stack the images together. I'm going to start with the one that's easier to do, which is going to be I. Select just the I images. Check. They are obviously lined up, and we can see some moon shine coming through there. They are lined up because there's obviously these stars are not moving. All the moving stars are cosmic ray hits. Process, align, stacks. Sorry, not align stacks. Combine stacks into a single image. For these, we basically want them to sum because we want it to seem like we actually took a 600-second exposure when really we took 200-300-second exposures. So click OK. And this is now a single image stacked on top of each other. And so I'm going to save that. Save as fits. And now because these are stacked, you know, we have to, they don't auto-populate the names like the other ones. So I usually do I so that I know that this one's the aligned and the I, and then save it. And now I'm going to go do the same one to the U. And now be a little careful because I have an extra file in there, but I named it I, so if I type U, it shouldn't pick up that one. And now I want to stack it, just check. Yeah, they do indeed seem aligned. Lots of cosmic rays around. Combined stacks. Some. Okay, here's the stacked version. Now go and save image, and then save it with a U. Okay, cool. Now that I've got the images stacked, we have to go over and check out our process document to see what the next steps are. Stack the images as you need to. I just did that. Make sure you're pointing at the right thing by comparing to laser images with, I think, north, up, east, left. So this is laser or wherever you found the source, which I found it under the TNS. So opening TNS, I have an actual picture of the thing that I should be looking at. And now I want to go over to my, open the right image. So I want to open one of my stacks. The blue image is super dim, so I'm going to start with the eye image, which is some kind of red type image. Somewhere in here, there should be a galaxy which looks just like this thing. Now, because that galaxy is super dim, it's going to be incredibly hard to find. I'm looking at the very center of the image. My belief is that the galaxy is that guy right there. But of course, I have to check. Notice the note that I made. I think north, up, east, left is the orientation of laser. That's not the orientation necessarily that we're looking at here, but it might be. So here are some tricks to try to figure out what source you're actually looking at. You can click on these images over here, and they'll give you a blown up version. It's tricky because I'm splitting my screen to show as much as you can of this thing. But this is now a blown up version of where the source actually is. So that's where the, I don't think I like what DSS is showing me here. I think I'll try this one instead. So blow up that guy. Yeah, because that one has a mouse interaction. Okay. So I'm just trying to zoom out to try to convince myself that I know where this thing is. So one thing you can do is you can tell down here is the field of view is 11 arc seconds. So you can try to make your field of view 11 arc seconds. You can see we have a field of view. That size is 2. So one thing you can sort of do is just be like, okay, where's 11? Okay, so zoom out here, this is 11. So a box in there is about 11. So you can zoom in so that that's about 11. You know, I'm sort of doing like an eyeball comparison so that between there and there is about 11. So that's about where that is. Yeah, now you can see it. You might be able to see the pattern. I can see it. There's that bright star. There's that galaxy, a much brighter galaxy. There's a bright star right there. There's like, I guess I'm not picking up this super dim galaxy. Maybe it's super redshifted. Maybe it's super far away. Interesting. But I believe, so it's so hard because like, I think it's that thing. Oh my God, this one is probably the hardest one that I've ever looked at because the stars just don't quite match up. That one is that one, okay. Yeah, that one has got to be that galaxy right there. I mean, look, it's halfway but closer over there. Okay, yeah, so I'm convinced that that is the galaxy I'm looking at. And actually, you know what? Look at the position of the supernova. I think the supernova is right there. So I'm not picking up any of these little things, so that's too bad. It would be a lot easier if I was. But I really think that it's this guy, and that's a supernova. Now, this is probably the worst case I've ever seen. But I do want to show you what the next steps in the document would be. So make sure you're pointing at the right thing. I think I might be pointing at the right thing. Make sure you have not saturated the source. We have not saturated the source. Saturating the source is like inducing bleed, like showing like this guy. There's no way. I mean, the number of counts on this thing. So look at the value and the peak. So the value is exactly where I'm pointing. The peak is the largest number of counts within the circle. I mean, the largest number of counts is 2,400. These chips saturate at 50, 60, maybe even 80,000 counts. We are nowhere near saturation anywhere on this image. You can even see down here, the histogram shows we're only at 25,000. So no problem saturation. Okay, cool. We've checked that. Check the signal to noise ratio. So signal to noise ratio is a technical definition, but for us, it's just the ratio of good stuff to bad stuff. Higher ratio, better, lower ratio, bad. This ratio is going to be awful. So let me show you a quick and dirty way to extract signal to noise information. So we're going to do real quick basic photometry. See the triple circles I have in my image here? So that this comes from, I think, turning that on. Oh, I don't know where it is. Turn that on. Yeah, there we go. So that button turns on the triple circles. So the triple circles is the photometer's key tool. The inner circle is all the source. There's a dead region, that's the annulus around, which is completely ignored, and the noise region is the very outer circle. So you want as much of the source in the inner region and as much non-source in the very outer region. So I'm going to zoom way in for this. You can see that I'm picking up lots of source, but also lots of galaxy. So I'm going to change the size of the circle. That's how you do this set. Drop it. Oh my God. I mean, I almost can't drop it any further, right? So drop it down to 2, I guess. Okay, that's also not great, but maybe what I have to go with. But you can see that the background is completely being dominated by the galaxy. So I think what I'm going to do is I'm going to make the background bigger so that, and try to avoid this cosmic ray hit right there. This is going to be a little stupid and a little, probably don't need to actually worry about this as much as I am worrying about it, but for the purposes of the video, why not? Cool. Okay, so that's not good either. I am now outside the galaxy, but I've still hit that cosmic ray. Let's see if I can, yeah, it's going to be super hard to do this. But I definitely don't want those 2 stars inside the background annulus, which they're dead inside. So let's try to split the difference and avoid the cosmic ray a little bit. This is, like I said, getting a little ridiculous. Let's do the very worst that we possibly can do, make that 8 so that the background is as small as possible. I can do better, right? I can make the inner image, the inner one, smaller. And actually, I might even be okay with covering that guy. So let me do that. That seems fine to me. Sorry, that. So actually here, I'm going to make the very outside ones 1 pixel smaller. This is ridiculous because the photometry is just so bad. But see, I'm still getting the galaxy. Okay. Okay, I'm actually just going to go with that. You can see that the annulus, the outer ring, is covering a little bit of the galaxy, but not much. The dead zone is covering a lot of the galaxy. That's good. That's going to be ignored. And then I've got the source in the middle. Okay, fine. Stop. Hold Shift and click the source. That's the key here. So hold Shift, click the source, and you'll get, oh God, I didn't even find it. Okay, so you see it jump down and said, oh, I know what you're trying to do. You're trying to get the brightest image in this region. So no, I don't want the brightest image in this region. Close that. Erase the annulus like that. I want to get the actual thing. I want to turn off centroiding. And I'm going to pause the video to figure out how to do that. Okay, it actually wasn't too hard. There's actually a button here that says centroid apertures. Normally, you definitely want that click. So if you don't quite click in the right place, it jumps it over to where the brightest part of the image is. In this case, I'm looking at a stupid dim source. So I'm going to just click it, Shift hold. Oh, cool. It stays there. Nice. So this is all the information about the brightness of the image. We could spend a lot of time looking at various things. Most of it is NANs because it doesn't really know how to calculate stuff for this hacked together image we have. But it should have the key thing we care about, which is the source signal to noise ratio. Hooray. So source minus sky is all the count in the source minus the sky, which is the background. And then it's doing some calculation and is putting out 15.75. So 15.75, we look back on our observation documents. Check the SNR, blah, blah, blah. It really has to be over 50. It really should be over 100. We are way too low. SNR 15 is ridiculous, way too dim. There's no way we can do any kind of photometry on this thing, even if we can see the source. So this is a bad source to pick. Let me go over and do the same thing for you. It's going to be even more ridiculous, but let's do it anyway. And then I'll tell you how to fix what kind of advice I would give on what to do about this. So let's do you. And again, we got to zoom in to try to figure out that we know what we're talking about. Remember, it was around here. Yeah, the U image is just so much. Let's do the same 11 thing. So how big is it? 11? 11 is about there. So I want to zoom into about here. There's that bright star. There's the stars down there. That is probably that bright star there. The galaxy is completely invisible. My source, totally invisible. I can't see it at all. But yeah, it might be that, but I can't tell. So I can't even get a signal to noise off this thing. All right, so what have we learned? We have learned that this star is way too dim. So that means that we need to change some of the notes. I'm going to put some notes up here to indicate that at 2 times 300 seconds, I had the signal to noise of 15 and invisible in U. That means that this is for T11, this is not a source that we can chase. And actually you can see that the magnitude of this source, if I go back to the TNS server, it's a little tricky because my window's in the way. I have to make it smaller. Okay, so if you go back to TNS, when this thing was first observed, it had a magnitude of 18. That is very dim for us. Not impossible, but you can see what happened was very difficult. So I'm going to make some notes about that. I'm going to go over to the source selection and say, way too dim, you could not stack. SNR of I was 15, stopping observations. Because the thing was just too dim. It was good for practice, but just too dim. If I was going to try to go after this source, I would do two things. I would change the exposure time to 600 in U, probably change to 600 in I for consistency's sake, and probably double it. So probably go to 2 times 600, 2 times 600 in both. Now we're sort of bumping up against cost problems because of that, but that's probably what we would need in terms of science. I don't want this video to go on forever, so I'm going to stop now. If this had worked, if you had gotten something that was close, like let's say your SNR is 30, 40, then what you would do is you would maybe change this to 4 times 300 to get a better signal to noise ratio. Check to make sure that the time you reserve on iTelescope was long enough to deal with that, because this is a 20-minute exposure time, which means I need at least 30 minutes, but really it should be more like an hour. So if you go to 4 times 300, maybe you want 90 minutes to make sure that you have enough time. Anyway, after you've made some modifications, go back to the observation document, add notes to the spreadsheet to indicate your changes. I'm gonna do that up here. Sorry. Add a column to the above table for the rest of the group to learn from. I'm going to do that right now. Add notes in the spreadsheet, indicate your changes. I just did that. Now I'm going to do one of these two things. If you had to change the plan, make the modification, go back to iTelescope, change the plan, set the observations for another like 3 or 4 days, and then check after the very next night and do the same process. Make sure the signal to noise is something like over 50. If the plan did not need to be changed, you still need to go back to iTelescope to extend the plan to cover something like 21 days. So 21 days should hit the peak and also hit some of the tail. You'll still need to monitor the source as it goes, but the monitoring process will be much more relaxed, because basically you'll get the images in your email inbox, and now that you know where the source is, I closed it. So I know about where that source is. So in the B images, I can kind of track it by eye. I don't need to go through and do the astro image J thing. I could just be like, oh, still there, oh, still there. And then at some point, it's going to be like not visible to the eye anymore. That's kind of when we want to stop the process. So the monitoring is much simpler than the process we've been going through here. But this video has already gotten too long. I apologize for that. But I think it's got enough information for the first night afterwards so you can continue the observation and build our knowledge of observing with these sources. You can see I didn't really think that. I mean, I have another T11 up here at about magnitude 18, and 1 times was under 10. So this is obviously my attempt to make it 2 times. Also didn't work. So, okay, that's it from me. Thanks very much for watching. I hope this has been helpful, and I will see you guys around.